Okay, now let's do some examples. For this question, we have a graph. The graph indicates the maximum kinetic energy of a particle. Okay, so that's the kinetic energy of the electrons when they escape. Okay, when they escape after struck by photons. And horizontal axis, we have frequencies. We have frequencies. Now, what we need to do is we need to find the minimum energy, which is the work function of a photon that can eject an electron from this metal. Now, remember our formulas? Okay? The kinetic energy, the maximum kinetic energy of a electron after escaping will be the kinetic energy of the photon, which is hf, take away the work function. Okay, let's use W. Okay, now look at this equation. Okay, and think about your equation like this. Your linear equation from math method or from year 10 math. Okay, y equals to mx plus c. So they are exactly at, well, they're the same type of equations. The idea is this: the horizontal axis is frequency. Okay, so our frequency is the horizontal, is the x. Okay, the vertical is kinetic energy. So we have your y as kinetic energy. Okay, y equals to mx plus c. M is the gradient, and in this case, the gradient is your h, which is the Planck's constant. So the gradient of this graph must be the Planck's constant. If you do a right over wrong, the gradient must be Planck's constant. And the y-intercept, c, okay, is basically the work function. Okay, so the y-intercept here is basically the work function. So when you have a graph like this, just remember the y-intercept down the bottom must be the work function of the material, the minimum energy that a photon needs to eject an electron, okay? Or the minimum escaping energy of the electron. Okay? So in this case, which is 1.8 electron volts. So the work function will be 1.8 electron volts. Done. Okay. Now let's go to question 2. Okay. So in this question, we have, well, we have experiment, okay, and the students actually set up this table. Okay. So, and we using this metal plates as photodiodes. Okay, so what he discovered was he used different color of light, different frequencies of light, okay, and he found the energy of the photon, and also he found the maximum kinetic energy of some of the other element. Also, he calculated the current. Okay, now we need to use the results to find the work function. Okay, just remember your equation. Okay, the kinetic energy equals to the energy of the photon, okay, take away the work function. So in order to find the work function, I need to know both the kinetic energy, basically the energy of the electron after escaping, and the energy that the photon delivers. Okay? So if you're reading from the graph, so from the blue light here and the UV light here, we have both. So from these two, we can find the work function. Okay? Let's use the blue light first. Okay? When we use blue light, the energy of the photon is 3. Okay, so just remember the energy of the photon is HF is 3 electron volts. And the maximum kinetic energy of the electron after escaping will be 2.1 electron volts. Okay, so we can have our equation. Solve the equation. Maximum. Sorry, I think I used the wrong number. We have 3 there and we have 0.9. So that's blue light. Okay, sorry, I read the wrong line. Just let me do it. So the maximum kinetic energy is going to be the energy of photon is 3. The maximum kinetic energy is going to be 0.9. Okay, so if I rearrange the equation, the work function must be 2.1 electron volts. Okay, so this means if I want the electron to be knocked out, if I want to get rid of the electrons of that cesium metal, I need to apply 2.1 electron volts of energy on a single electron to make it move away from the nucleus, from the metal plate. So so if you do the same thing, if you use the same value, if you use those two values, you should get the same answer. Okay, you can try it now. Okay, the important lesson is here, the current. Okay, current is the indication of the number of electrons. Okay, and the number of the electrons has been knocked off is related to the number of photons. And the number of photons of the incident light is basically the intensity, the brightness of the light. Okay. If the current is different, it means just the intensity of the light is different. This has nothing to do, the current measurements has nothing to do with the energy of a single electron or the energy of a single photon. It has to do with the number of the photons and the number of electrons.